I think I can just say for future presenters, if you haven't allowed screen recording permissions for Zoom, you're not allowed to share your screen. So to test that out before is probably what happened.
I didn't realize that was a thing.
How do you test that?
If you go, if you're on a Mac and you go to System Preferences, and then you go to, I think it's Security and Privacy. And then there's like a tab at the top right that says Privacy, and you scroll down and it says Screen Recording. And then there's apps that you allow to record the content of your screen.
On a PC, it's usually not a problem in my experience, but on Macs, the more recent Macs have been like locking everything down pretty much.
Can you see my screen right now?
Yeah.
Cool. Yeah, sorry for that, sorry.
Thank you for the heads up.
So here. There I go. So hello, hi everyone. I'm Noel, and I will present you the PIC-SURE platform that is developed at Avilac Lab at Harvard Medical School. So the PIC-SURE platform is part of the Biodata Catalyst initiative that has already been presented. And it's basically a tool to allow investigators to first studies and explore the variables and the different studies that are available through the Biodata Catalyst into Biodata Catalyst, and then to retrieve those data directly using PIC-SURE. So the studies that are available are the TopMed and TopMed related studies. And PIC-SURE got two main components, so a graphical user interface and an API. And I will do live demo to show you how it works. The graphical user interface, it's the components that allow investigators to quickly and easily search available data and to conduct feasibility queries, that is to explore whether given the available data, whether they could explore and conduct epidemiological studies that would answer their hypothesis. The API allows both to explore the available data through an object that is called variable dictionary, and also to download directly the data into into a tabular format that is very easy to work with directly into Python and R programming languages. That's it, the graphical user interface. So right now it's only it's only allowing investigators to explore phenotypic variables, but soon the genomic variables will be added, and it works by entering part of the variable names, that is words that are part of the variable names, into the search bars, and it will search across all the available studies which variables are related to the term you've been entering into the search bar. You can also access the harmonized variables. So there is 43 harmonized variables that are phenotypic characteristics that have been harmonized across multiple studies. That is, for example, the age of every patients of the more than 20 studies available through PIC-SURE are available in a single variable that is called age in the harmonized variables. And so this mechanism allows investigators to refine cohort, and through a mechanism of subsetting, they can only download the patients that they are interested in, the patients that match the criteria they are interested in, and only the studies the variables they are interested in. And you can download the data through only with a click of a button. And the R and Python API, it's the same mechanism for users, so more seasoned users. You can explore the available data, and you can directly download those data very easily. So I will show you how it works in a practical way. So here is the biodata graphical user interface land page. You connect using your ERA commands credentials, and you end up in this landing page. So here is a search bar you can where you can type any word that will match variables available across the different studies. So as an example, we could say we are interested in patients that are smoking, that have been smokers in their lives, and we also want a subset on the age of those patients. So we can type just smoking in the search bar, and here we got all those first two rows is the name of all the studies that contain at least one variable which match this term here. And you can browse the different variables that match your query. And so here we can go to the COPD gene study and select these variables. And once you select a variable, you are able to filter based on the value of the variable. So to include the patients that have been smoker, we enter yes, obviously. And here we got the number of patients that match our criteria. You can add multiple variables to refine your cohort. And so here, using the age, we can use the age at enrollment in the COPD gene study, and subset all the patients that are less than 60 years old. So here we see that our study, our population is of 5,364 participants. And now if we are satisfied with this search, we can download the data directly through the graphical user interface. And going through that, we select only the COPD gene cohort. We see that we got 341 variables, and then we click on we got to click on prepare data for export and then download, and you got a CSV file that is very easy to deal with. It's in a tabular format. So for instance, it's all this mechanism allow you to easily work with big studies, such as the Framingham cohort study. Basically, this study is, if you use the dbGaP files, it's more than 100 files. If you use PIC-SURE, you get your data in one single CSV file, which is very handy to use afterwards. So here, jumping to the second component, which is the PIC-SURE interface, the PIC-SURE API, sorry. We developed several example notebooks that are publicly available on our GitHub page and also on 7bridges platform, as well as on Terra soon, on the Terra platform soon. And so I will go through quickly go through these notebooks and explain you quickly how the API works. And you can find all the explanation and all the details on GitHub. I have provided the links on the slides. So this notebook is a PIC-SURE 101, so it's a more detailed one. Start from here if you're a new user. It's the first step always when you're using PIC-SURE is to get a security token. So it's an individual security token that has a time-limited validity. You get it through the interface. When you're logged in into the graphical user interface, you go to user profile again, and then here is your token, and you just copy it very easily this way. And you copy paste it into your environment, into a text file that is called token.txt. And this mechanism is explained in a fourth notebook, actually. So it's explained step by step here. So once you got your token copy pasted into your environment, you can start using PIC-SURE API. So the first step is obviously to install the API from GitHub right now, this way, and then to import all the library needed for your analysis. And so there is the first step is to get a connection to the database that hosts the data. So here is the way, the simple snippet you have to use to get access to the data. And here is all the only information you need to provide to get access to those data. Once you're done with that, you can see that you can first get a dictionary of the available variables. So here is how the variable dictionary looks like. So there is one row per variables and one columns which give indications of several indications about those variables, whether those variables are counts, categorical or numericals, and you can subset your cohort using the information provided by this dictionary. So that's what I do in those different notebooks. So here I subset using the term medication history and medical history. And in the end, you can retrieve the data using another object, which is called, resource.query. All the methods to retrieve the variables are explained here. And you retrieve the variables in a few lines of code. And then you can conduct your analysis because it's just the data you've been retrieved, which is just a regular pandas data frame. So in Python, it's the state of the art to deal with data. So here it's a trivial example on the PIC-SURE API 101 notebooks. There is a more complex one. It's the PHIWAS notebook. So it's PHIWAS stands for phenome-wide analysis. So here we're using the COPD gene study, and we go through all the steps needed to retrieve your data using PIC-SURE API up to your PHIWAS analysis, and which end with a Manhattan plot. So all the details to understand this process are given in this notebook. And the third one is working with 43 harmonized variables. So those harmonized are all available through the API too. Here is how the variable dictionary looks like for those harmonized variables with all the components. So you can see that we got more than, for some variables, more than 200,000 subjects. And in the end, we choose to represent in these notebooks the sex ratio of the participants which have been included in the harmonized variable process. for each study, each of their original study here. So these are the Python notebooks. There is the same one in R. Here it is, and in the end, it follows the same process. It's just explaining how to use the R API, and here is the sex ratio for the harmonized study, just as I showed you in Python. And it's worth noting, so those notebooks are available publicly on GitHub and on 7bridges right now. You can go to the 7bridges landing page and click on public projects and then PIC-SURE API, and you will get all those notebooks directly available without having to download anything from GitHub. And moreover, those notebooks are have also been converted in our Markdown format, so to be able to be used through the RStudio server from 7bridges. So here I'm good with the explanation of the API and the graphical user interface. So there is more information on our GitHub page. I provide the link on the slide. And yes, so the 7bridges workspace is already available. We are working on making the Terra workspace soon available for everyone. And regarding the policy of PIC-SURE, we follow the biodata catalyst policies. That is, on the graphical user interface, you can only get exact counts when your criteria concern more than 10 patients. If there is only less than 10 patients that match your criteria, you will get less than 10. And when there is no patient that match your criteria, you would get a 0. So, and you're able to download only, no, you're not able to download every available variables right now. And so here are all the useful links to get started with PIC-SURE. And so here it is. Here it is. I'm done, so I try to exit. I got to exit here.
Great. Looks like we have time for questions, if there are any. I'll start with one quick one.
Right.
Can you give us a quick explanation of the difference between Gen 3 and PIC-SURE, and maybe a use case for why a user would pick one over the other?
So I'm not sure exactly of the real difference. Using the graphical user interface, I think you can, on PIC-SURE, you can download the data, and the mechanism to search and to refine your cohort is not the same as Gen 3. Also, the PIC-SURE API allows you to not only allows you to download the data, but also through the variable dictionary that I've been quickly showing, it allows you to first select the variables you're interested in, to subset your code directly from from Python and R. So those are the difference that came to my mind. I know there is other ones, but I'm not that familiar with Gen 3.
Yeah, I think that it's accurate to say that some of the search functionality, that free text search that's available in PIC-SURE, is not currently available in the Gen 3 implementation in any of the NIH systems. It is something that's coming down the pipeline, so we'll see some increased similarities between the two in the term. And then the other kind of differentiation is in Gen 3, we have the link both to the phenotype data that's been harmonized and made available across the across a few different NIH systems, and that linked with genomic data objects as well, so that folks can then send off to TERRA, send off to Seven Bridges in the future, and run analyses paired with the genomic data itself.
Thank you.
This is Allison from Seven Bridges. I'll just chime in. I think one really cool aspect of PIC-SURE is that for researchers who are kind of at the beginning steps of doing a GWAS and thinking about the phenotype that they're interested in looking at, they can use that free text search to understand all the different phenotypic variables that were measured in the different TAPMed studies. So that can really help them when they're getting started with planning out their GWAS.